Given that p and q are integers such that pq is even, use algebra to prove by contradiction that at least one of p or q is even. So we'd like p and q to both be odd if we're going to make this contradiction. So let p and q be odd. And we want them to be independent odd numbers. So we can say that p is 2n plus 1, where n is an integer, and q be equal to 2m plus 1, where m is an integer. And then consider pq, which is 2n plus 1, 2m plus 1. Expanding out, that gives us 4nm plus 2n plus 2m plus 1, which we can write as 2nm plus n plus m plus 1, which is odd. And there is our contradiction. So for PQ to be even, one or both of PQ needs to be even. Now let's look at part 2, which says that given that x and y are integers, such that x is negative and x plus y all squared is less than 9x squared plus y squared, we want to show that y is greater than 4x. So let's start with the x plus y all squared is less than 9x squared plus y squared. Expanding the bracket on the left gives me x squared plus 2xy plus y squared is less than 9x squared plus y squared. We can subtract y squared from each side, giving me x squared plus 2xy is less than 9x squared. Then we could take x squared from each side, which would give me that 2xy is less than 8x squared. Now I can divide both sides by 2x, but I have to take into account that x is negative, and that will reverse the direction of the inequality. When I divide 8x squared by 2x, I get 4x, and we end up with the result that we want.